calculate the MCR by referring to this equation. Okay, this is where for the case of the beam where the bending moment diagram linear along the segment. Okay. Okay. Why is it segment? Segment, what does it mean? Segment means that, okay, you can have a beam, okay? You can have a beam, but with a specific location that restraining at specific point. Apa maksud itu? You can have a beam, like this beam. Like this beam. And then you have, let's say, precast slab. Precast slab. Mananya orangnya? You can have precast slab. For precast slab, apa maksudnya? Precast slab will not provide any restraint. No restraint to your beam. Okay? If you use precast slab, so it cannot provide any restraint. Means that the top flange are able to move sideways and rotate and twist. Okay? Means that you need to design your beam as unrestrained beam. Okay? But the thing is, for beam, you may have another structure member that attach to it or connect to it. It will connect. And this connection and this structure can provide restraint at this specific point. So that's why we said, when we design, we said it as segment. A to B, okay, B to C. A, we have another connection. Another connection. So means that this point also cannot move sideways. We have restraint too, means it can provide restraint. Means that in this case, for this beam, A, B, C, point A, point B, point C, at this specific point, there will be restraint, dihalang. But in between A to B, unrestrained. This B to C, unrestrained. So when we design, we have two segments. Segment 1, segment 2. We have two segments, means you need to calculate MBRD for segment 1, also MBRD for segment 2. That's why in this Eurocode, it said segment. Okay. It said segment. Ada kan? Mana tadi? It's okay. This one. Linear along a segment. Means that there will be if the moment diagram is linear along this segment, so there will be certain factor that will be 0. For that, okay, C2, Z2 equal to 0. For that, this equation will be, you can ignore this one. This is 0, 0. So what left is only this parameter. Okay, so we simplify your equation. Okay, for uniform doubly symmetric cross-section loaded through the shear center at the level of the center of the axis and with standard condition of restraint, MCR can be calculated using this equation. This is for doubly symmetric cross-section like your I section, your H section, okay, and then with typical case, yeah, where the loading pass through the shear center, and standard condition of restraint means that just a typical pin or fix, and this is the MCR that you can use. Okay. Okay. What is C1 and C2? Panjang sikit penjelasan Oh, okay. What is C1 and C2? C1 and C2 is actually parameter. I would say parameter that involve in calculating the MCR. Mana? Let me see. Sorry. This is C1. C1. The original equation involves C2. This one, C2. We have C2, we have C1. Okay. To determine the C1 and C2, you can use table 6.11. Okay, for further information, not further information, all the information I already put in my module, but the original document you can refer to SN003A ENEU. Okay, you can look for this document free from you can Google it, okay, and then you can read. Okay, it will explain about C1, C2, MCR, actually MCR. So you can use table 6.11 and table 3.1, which I already uh, uh, extract that table in this module. Okay, C1 and C2, okay, C1 and C2, you can base on table, you can base on, the diagram, this table referring to diagram like this one. Or you can calculate manually using equation. Okay, this is the equation for C1. Okay, C1, okay, I do not remember how to pronounce this symbol. I do not remember the Latin. Okay, but this is the ratio of end moment. Nisbah moment kat hujung. Okay, nisbah moment di hujung. Okay. So, okay. Apa lagi? What else? Okay, you can refer to this. You can refer to this document. Yeah, you can download it from internet. Okay. Why we need MCR? It's quite tedious, right? Very lengthy procedure. And then involve a lot of parameter that you need to refer to table, the diagram. Sometimes you have to you have to compute using another equation. Okay, lambda bar LT can be, okay, you need MCR to calculate lambda bar LT, but lambda bar LT can also be determined without MCR. You can use simplified expression. You can refer to this document. Okay, this is the name of the document. You can look in the Google, and then okay, this is the simplified approach, but this formula only for roll I section and channel section with non-destabilizing load. You can use this one. Lambda bar LT 1 divided by C1. C1 you can use that equation, this one, table or this equation. Okay, and also I provide you Okay, with the link, you can refer to this link to, okay, see, this is the link. This is the, ini yang mana ya? Okay, this is explanation for lateral torsional buckling. Okay, what is lateral torsional buckling? What is the effect, the slenderness, and then about the C, this one is C, CS, and then this is how to calculate MCR, but this one is for doubly symmetric section, like our section, I section, H section, that is doubly symmetric. And then what is the shear center here? Shear center. Okay, and C1, C2. Okay, and then don't panic, you can determine lambda LT without MCR using this equation. Okay, it allowed you to use this equation. So without hassle, you can opt for this approach. Okay. Jelas tak penjelasan saya? Boleh faham tak? Saya tahu banyak benda nak buat macam ni, dia memang banyak. Okay. Okay, so now we go to example. I hope that by referring to the example, you can have clear picture on what we have been discussed just now. Okay, so for this example, we have one beam A to D, but at point B and point C, we have another beam that connected to this beam, yeah. These two beam connected at B and C, yeah. Okay, another information that we have, okay, we have, it is simply supported beam. First, it is simply supported beams, means that simply support, okay, with simple connection, of course, simply support beam. And then we have, okay, it is 10.8 meter. Then we have two secondary beam. Secondary beam, okay, that passing through B point and also C point. We have two secondary beam. Once we have another element that connected to that, to this structure that you want to design, you need to justify whether the connection can provide restraint or not to this element. Okay, it depends on the detailing. I said that it can be considered as restraint once the type of connection that you provide or you restrain the movement of the top flange. Ingat bukan semua boleh jadi restraint. Bila top flange tu tak boleh bergerak, then you said it is restraining that specific point. Okay, and then okay, secondary. Okay, the secondary beam are connected through fin plate to the web of the primary beam. Normally, okay. What's that mean? That means this is the main beam. Yeah, this is the main beam, and then you have secondary beam. It could be like this. If the secondary beam using the same size as the main beam. For the same size, of course, you have the same height, right? If it is smaller, you can attach like this. And then using fin plate. This is fin plate. Fin, maksudnya apa? apa ikan punya fin tu apa? Sirip. Sirip Okay, fin plate. Fin plate. This is fin plate. Nampak? This is fin plate. You will using one or two plate. Not angle. Plate. Plate means this is plate. Plate. And then you have another plate here. Normally we use two. And then this is where the web masuk sini. Okay, web goes here. Okay, and then connect. This is fin plate. Fin plate means pin connection. Okay, and then normally we need this flush. Dia sama rata, flush. Okay, dia sama rata. Otherwise, your slab here ada step. If it is not flush, okay, your slab will not be in the same same level. In the same level. Okay, so considering that, okay, by considering that, of course, you can see, can this top flange move sideways? Stop your Hey! Can this top flange move sideways? Boleh ke move? See, tak boleh move. So, restrain. Dihalang. Okay? So, it depends, So, you have to justify. Okay. So now we know that our B and C point is restraint point. Is restraint. The restraint provided by the secondary beam. Okay, it's being provided by the secondary beam. Okay, what else? Secondary beam are connected to the web and full lateral restraint may be assumed. Okay, select suitable member. Okay, the primary beam. Okay, so ada nak tanya? Is there any question? Okay, first, of course, you need to perform the analysis. I'm not going to explain this one. Okay, you should by now master this thing. Okay, so this is the analysis. You have the GDR, you have the GML. Okay, what's next? Okay, we know that, the thing is, we know that this beam is restrained at A point, B point, C point, and D point. So we have like a segment 1, segment 2, segment 3. In this case, I said that for each segment, you're gonna have its own MBRD. You need to access all unless it is it is symmetry. If it is similar case, symmetry, I mean having similar span, so of course the MBRD for segment 1, segment 2, and segment 3 will be the same. The thing is, in this example, it is not symmetry. You can see here, A to B, we have this value of bending moment. It is not similar. And also the span are not the same. So we have different MBRD for AB, BC, and CAD. The thing, okay, the other, to simplify our calculation, instead of having to calculate 3 MBRD, you can, make certain judgment. Which span is much more critical in terms of MBRD? What is MBRD? MBRD is buckling. What can you understand about buckling? The longer span, longer span will prone to buckle. So my judgment is segment A, B, only having 2.5 meter distance compared to 3.2 compared to 5.1. I bet 5.1 will have smaller MBRD, which is smaller resistance, means that is the resistance that govern the design, kan? Ingat, kekuatan yang kecil tu, itulah kekuatan struktur awak. Jangan ambil kekuatan yang besar. Sebab dia akan fail dulu kat situ. Okay? So, my judgment is 2.5 is not significant. Because of the span. That's one thing. And the other thing, the moment at span AB, we have 0 moment at A, 1000 something at B, compared to 0 moment at D, but maximum moment at C. On top of that, this is the longer span. So it more prone to buckling. So it could be critical. 5.1. What about 3.2? I could not avoid 3.2 because I know 3.2 is much shorter than 5.1. But the thing is, at segment 3.2, I have 2 moments. At B, I have 1000 something. At C, BC have maximum bending moment. So I cannot avoid this segment. What I can skip is considered only by avoiding or drop this segment. Okay, so I'm going to focus on segment 2 and segment 3. Okay, now both I need to calculate MBRD. Okay, so for MBRD, okay, first of all, of course, you need to perform the section classification. Why? Because MBRD also, the equation also depends on the section classification. Okay, I will not go through this one. I just, go through a bit fast. I said that for unrestrained beam, MBRD is the additional checking. Means that you cannot avoid perform shear resistance check. You cannot avoid perform shear buckling check. Moment MCRD. This one is MBRD. What we will focus today. You cannot avoid MCRD. Oh, tak ada dalam ni. Okay. You still need to perform MCRD. We do not have that checking in this example. See here MCRD. Deflection. Still you need to carry out that. Okay. On top of that, you have another additional checking, MBRD. So I'm going to focus on MBRD for today's lecture. So MBRD, you know that it is chi LT, WY, FY divided by gamma M naught, and chi LT, you can go through 6.3.2.2 or 6.3.2.3. This one is general case. This one for roll and equivalent welded section. Okay, you can go for this option. Okay, so in this case, it's using, I think, general case ke? Let's see. Saya tak sure. Okay, general case. Using general case. So for general case, refer to clause 6.3.2.2. This one. 6.3.2.2. This one. Chi LT, Phi LT, Alpha LT, Lambda bar LT. Lambda bar LT in this example, it show you how to calculate MCR. Okay, I'm going to focus on how the MCR being calculated in this example. For segment BC, the span length is 3.2. Span length, you need to consider critical span or effective span. What is effective span? You've been taught about this one. I hope that you remember. For simply support, okay, critical span, the buckling curve will be start exactly at this point, yeah. So LCR for pin will be 1.0 L. What are the difference of LCR and L? LCR is the buckling length, panjang buckling. L is the span between restraint to restraint. That is L. L adalah panjang dari restraint ke restraint, sedangkan LCR adalah panjang buckling. And okay, consider the second case. We have fixed and fixed. The buckling will start at certain distance away from the end point. Okay, this is the buckling, means that this is the LCR. Fixed span is restraint to restraint, means this is restraint, this is the restraint, this is L. But LCR will be 0.7 L. I hope that you still remember this one. You dah belajar You dah belajar. Okay. That is LCR. Okay. So here, LCR for this case, for segment BC, because this is pin, right? Pin to pin, 1.0 L means that 1.0 times the L is from restraint to restraint, 3.2 meter. That's why the LCR is 3.2 meter in this solution, 3.2 meter. Okay, MCR, because it's using I section with typical load case, typical end condition, just pin and pin is typical. Okay, so you can use this equation. You need C1 pi, you have pi E, you have E 210 000 at the back. Isaac is what is Isaac? Apa dia Isaac ah? What is Isaac? Isaac apa? Wow, saya dah cakap banyak Saya tak tahu you ada ke, entah you pergi makan ke, tinggal saya cakap seseorang. Saya nak panggil. Tak ada, saya kick terus. Abdi? Abdi Majid? Abdi Majid?
Ya, yes, doktor.
Okay, what is L, Abdul Majid? What is L?
L.
What is L?
I did.
I just said just now, I think not more than 5 minutes. I just said it. You are not concentrate. Okay, it's okay. I understood. Aiman. 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 Apa L? Apa L? Akmal? Akmal? Buat apa nak datang? Buat apa nak datang Akmal? Dia nak tanya pasal hari ni punya subjek. Hari ni kan saya tengah ajar. Tanyalah sekarang. Saya dah tanya dah ni. Apa saya nak blur? Tanya sekarang. Boleh tanya. Atira?
Ya saya.
L tu apa Atira? Baru saya tanya satu L baru.
Length.
Length
From restrain to restrain.
Restrain ke restrain. Bermaksud kadang-kadang bukan panjang beam tu dia mesti panjang restrain ke restrain. Okay? So how many L you have here? You have L1, L2, L3. And the total L, the span, is different, okay? L is different from the span. Okay? Unless you have simply supported beam with no intermediate restraint in between the span. Okay? Okay. Saya pun dah tak berapa ada bateri ni. Point jauh sangat kalau saya nak connect pun. Okay, so just go through just one segment. I'll just do it with you for one segment. B, C only. You do it the rest, okay? So C1 you can calculate manually. Okay, I said that this is the ratio of end moment. Ratio, nisbah end moment. Moment hujung. For BC, the ratio is smaller moment to big moment. Direct translation. Okay. You have for segment BC, remember BC you have two moments. This is the end moment. So what is the ratio? This value, the smaller value to the large value. Okay, that is the ratio. So that is the value for this symbol which I could not remember how to pronounce, how it been called. I do not remember. Okay, this one. Once you get, then you can put that value into this equation. You can work out the C1. Okay, make sure that C1 is less or equal to 2.5. If it is bigger, just take C1 as 2.7 if it is bigger. Okay, then once you have C1, L here is critical span, LCR. Okay, LCR, put that, LCR. For buckling, you refer to LCR, not total length. IW, IZ, LCR, IW, IZ, E, IZ, IT, all you can get from Blue Book. Okay, from the Blue Book. Do I have Blue Book here? Blue Book. Wait a second. Okay. I just want to show you what is IZ, IT. Okay, all the parameter you can directly get from this table. Okay. This is IT. This is IW. This is W. This is Isaac. Isaac is here. Semua ada. All you can get from this table. Isaac, IT, IW. L critical is, in this case, 3,200. Okay. You have C1, right? We just calculate C1. And then put the other value into this equation and then compute the MCR. Okay, we have MCR here. Once you get MCR, you can get lambda bar LT. Once you get lambda bar LT, then you can get the other parameter. For this class 6.3.2.2, alpha LT based on table 6.4, right? 6.4, see? Ni. This is class 6.3.2.2. You need to refer to 6.3 and also 6.4. In this case, you have to evaluate the ratio of H over T. If it for less or equal to 2, buckling curve A, bigger than 2, buckling curve B. I will not do part by part. You are not school student. You are university student. You should just understand H over B. Okay, you can get H, you can get B. Okay, in this case it's bigger than 2. Okay, for buckling curve, you can use buckling curve B. Once you get the buckling curve, then you can use table 6.3 to determine the imperfection factor, which is alpha LT. You need alpha LT, right? You need alpha LT in order to compute phi LT. Okay, phi LT. In this case, you can refer to figure 6.4 without having to calculate phi LT, but just follow the solution. Okay, for this example, the solution using phi LT, it compute the value of phi LT. In this case, okay, phi LT 0.71, and then substitute into phi LT equation and then calculate, make sure it is less than 1. If it is bigger, what you have to do? Just consider phi LT, chi LT as 1. That is the maximum limit for chi LT. And then once you have chi LT, you can have MBRD. Okay? So in this case, MBRD for segment BC is 1,469. Okay. Okay. MBRD 1,469 kilonewton meter. Moment So kilonewton meter. For segment CD, I will not do it with you. I need you to do on your own. Just remember, this is different segment, different span. So recompute C1, recompute MCR, okay, and then VLT, KLT, and BRD also different. For segment CD, the MBRD is 1,402. 1,402 kilonewtons. So in this case, this is 5.1, 3.2 meter. In this case, this segment will bend first. Okay, it will fail first compared to the segment 1 and segment 2. So, in this case, you said the MBRD for segment CD will govern this design. Dia yang kawal semua ni. It will, because it is having less resistance, it will fail first. So that will be the strength. Consider the ultimate strength for this structure. Dia akan fail dulu. Jadi apa-apa kekuatan berdasarkan keupayaan dia saja. So MBRD 1402. Okay, so this 1402 you need to compare with the MED. What is the MED? MED is the maximum moment that you get from your analysis. The MED is 1360 to 1362 kilonewton meter is still less than resistance, means okay, pass. Okay, it means that with the size it's still able to carry or to support the applied moment, or MED. That's all. That's all what I want to highlight today. You cannot get this knowledge with just listening to me tonight. Okay, I bet you cannot get all the digest all the information only by listening. You need to do the revision, to do the calculation, compute the value from this equation. Okay, then you can fully understand. Yeah, get yourself get yourself familiar with the equation involved, with the clause that you need to refer to. Okay, then you can have confidence to solve this problem. Okay, so that's all for tonight. Okay, saya tak boleh tahu sebenarnya. Saya cakap dengan awak lah, kalau luar negara dia tak ajar macam Malaysia lah. Masukkan equation dalam ni, no, tak ada punya. Dia tunjuk awak macam ni, ni. Go through example sikit, explain. Buat. Tak ada, dia takkan ada kira sama-sama, tak ada. Okay, so awak kena tahu buat, kena rajin. Tak boleh, bukan budak sekolah nak satu-satu. Okay. Example 3.5 ni apa benda? Okay, example 3.5 actually is from I think this one test or final exam. Past year okay, you can try to do this example. The good thing about this example is that you can learn how to calculate beam self weight by using the density. Okay, actually you have to know how to calculate beam weight, because just a mathematic. Berat. What is equation for mass? Weight. Kan? Mass, jisim. Mana sama dengan weight? Kena kali dengan gravity, then you can get the weight. And then, okay, propose initial size. How to propose initial size? To propose initial size, I said you can I would put as a manipulate. You can manipulate any equation. The most practical equation using bending moment equation, MCRD, because this is about beam, right? The question is about beam. Beam is bending member, bending member. And then normally bending will govern design. Normally, most of the case, bending will govern the design. That's why when you look for initial size, we go to this because this is critical. But it will not always the case, because sometimes deflection will be more significant compared to bending moment. That's why sometimes you see in another example, in order to get initial size, nak dapat initial size, it manipulate deflection. We know that the actual deflection should less than the deflection limit. Worst case scenario, it should be the same. Same thing goes here. MCRD should less than MCRD should bigger lah. Should bigger for the safe design. MCRD should bigger than MET. Worst case, same to the MET. So based on this, based on moment, you can get the unknown factor of I. I kan? MCRD is equal to, oh no, sorry, W modulus. Based on deflection, the unknown will be I. Based on this, refer to blue book and choose W or I that's slightly bigger than the required value. You get here W required, I required. From blue book, you provide W provided or I provided that's slightly bigger than the required. Why? Because remember, this is just one checking. You still have shear, you still have moment, you still have buckling, MBRD that you need to carry out. And there's a one more for beam. I need to teach you one more checking, which is also having lengthy procedure, which is called as web buckling and web bearing. We call it as a web resistant. Lupa. Last time we call it as web buckling and flange buckling. Web buckling, web bearing, and flange buckling. Flange, instead of having failure for I section, this is failure, this is also failure. It failed because of if it's bigger than the limit, the deflection. Okay, buckling, okay, beam, buckle, this is also failure mode. If it is exceed the allowable. We have another type of buckling mode where we're afraid that the web will buckle or flange buckle. So this is what we need to do. This is web buckling, web bearing. Check. Oh, sorry, flange also. Okay. Ada lagi. Okay. I think I need to appreciate to those who come today. Okay. As usual, I need you to answer this question. Let's say this is quiz apa ni? 5 4 5 lah. is 5. 5, this is me. Okey, nak tanya apa ni? Hi LT saya tak tahu macam nak eja dia. I don't think I can put the symbol here. Kai boleh kot simbol. Ada simbol. Ada simbol tapi boleh Kai. Do we have Kai? Tak ada. Tak nampak. So I just put Kai. Dia spelling not sure whether the spelling is correct or not, but I hope that you can understand. Okay, that's all. This one. Okay. And then let me adjust, let me edit the timeline because it's quite it is not difficult, but I think you need more time. And date, yes. Quiz, okay, and date. Okay. Time should be 9, 10 lah. 10 p.m. Okay. 10 p.m. Okay, You can access the assessment, the assessment, but allow me to, okay. Okay, that's all I will consider for your attendance for today. So, happy answering the question. As usual, if you face problems with the author, you need to let me know within this time frame. Okay, not tomorrow, not this midnight. Okay, within the time frame until 10. Okay, okay, bye. Allow me to sign off, but you continue with the quiz. Okay, bye. Bye semua.
Doktor,
Yep.
nak tanya pasal second batch punya Eurocode dengan modul tu boleh ambil bila
Ni yang dah bagi nama
dah bagi nama, dah bayar dah.
Okay. Buku kat kedai nanti saya ambil. Esoklah saya tanya dia. Esok
Okey.
saya tanya dia. Okay.
Terima
Bye.
kasih doktor.
Okay, bye. Habis.
Thank you, doktor.
Terima kasih doktor.
Bye.